the sinusoidal graph, where we're going to work on the Ferris wheel. So imagine you're at the fair, and you see that Ferris wheel going around. Everyone visualize it in your head what a Ferris wheel looks like. Notice on the next slide, I did throw a picture up there so you can see it. Now, I did create a graph on the right of this that kind of shows the dimensions, and we're going to talk through it. So you have a Ferris wheel. It has a diameter of 30 meters. So the distance from here to there is 30 meters. With a center of 17 meters above the ground. So if I take the center and I go to the ground, I'm at 17 meters. Now, we probably all can identify the radius halfway from through the diameter, right? So this is my radius. What is the distance off the ground? Or imagine you getting up, you know they have those ramps that you walk up on to get into the Ferris wheel little cart? What is the height off the ground the wheel is? 2, right? So this is 2 feet off the ground. Oh, 2 meters. Yeah, I changed it. All right. 2 meters here. Thank you. So the time it takes for one revolution is 60 seconds. So 1 minute around is 60 seconds. So what we're going to do is we're going to graph this function. All right. And I've already set up on your PDF the time and the height. And you'll see where this comes into play in just a moment. So the bottom of the horizontal axis is your time in seconds, and the vertical axis is the height off the ground in meters. All right, so imagine the Ferris wheel, you get on the Ferris wheel. The time is 0. Where are you in respect to feet off the ground? 2 meters. Yep, you're sitting down, you're off the ground at 2 meters. So that would be our first order pair. Here's 2 meters. Then, you know that it takes 60 seconds to go around the Ferris wheel, right? 1 revolution. So let's go back up to here. So if here I am, and we say the Ferris wheel comes to here, a quarter of the way, how much time has gone by? 15 seconds. A quarter of the way is 15 seconds. Where am I in respect to the distance from the ground? 17 feet. Yep, or 17 meters. Yep, 17 meters. Let's go ahead and graph that order pair next. So after 15 seconds, I'm 17 meters off the ground. Then, I go another 15 seconds. Where am I at now? Now you're at the top. So now at 30 seconds, you're at the top. How far am I off the ground? 30 feet? 32 feet. So go back and graph it. At 30 seconds, I'm at 32 feet. Meters. All right. See if you can find the next 2 ordered pairs for 45 seconds and 60 seconds. All right, I just made a little dot here in the red. Now I'm 3/4 of the way around the Ferris wheel. I've gone how many seconds? 45 seconds, and how far am I off the ground? Back to 17 meters, yep. And then at 60 seconds, where am I at from the ground? 2 meters. All right, so we'll go ahead and graph those. So at 45 seconds, so we're at 17 meters. And then at 60 seconds, 1 revolution has gone by. We're back to our starting point of 2 meters off the ground. So if we go ahead and create that first revolution, it is a cosine function with a reflection. Do you agree in that? Where is it starting at? Starting at the bottom, right? At 2. So it's going to have a reflection. All right. So we're going to find the A, B, C, and D. So far, so good? All right. So let's go to the next slide. Find the equation of the graph using the cosine function. So here is the cosine function equation, and I just changed it to h of t, height and time. So let's find the amp first, like we did in the order of the last problem. To find the amplitude, what am I going to do? Subtract the maximum minus the minimum and divide by 2. So max minus minimum, divide by 2. So see if you can find the maximum height and the minimum height and divide that by 2. You get a maximum height of 32 meters, minimum height of 2 meters, and you divide it by 2, and you get 15. So our amplitude is 15 meters. Now, our A, we already talked about, has a negative, right? So it's going to be a negative because there's a reflection starting at the bottom. So now we've taken care of that. Let's do the B next. So we've done the A, let's go to the B. B is found from the period. How long is the period? How long is 1 revolution? 60 seconds. Good. So we need to find the B. Period equals 2 pi over B. I'll give you about 30 seconds, see if you can find the B. Okay, so you can substitute 60 in for the period and solve it for B. So multiply both sides by B. Then divide both sides by 60. Reduce it by 2. And you get pi over 30. So now we know our B. Now let's talk about our C. If we go back to our graph at the bottom here, do we have a phase shift? Did we move it at all on the horizontal axes? No, we don't have any phase shift to worry about. It's starting at 0, 0. So our C is not there. It's a 0. Now our D. Our D is our phase shift, our vertical shift, right? Moving up. Did our graph move up? Yeah. Can you visualize it? You might be able to visualize it from the graph. Where is it at? Going up. Let's check it out with our equation. Okay, so we said our C is 0 since there is no horizontal phase shift. And then to find our D, our vertical shift. Do you remember the equation? Add them and divide by 2, yep. So max plus the min divided by 2. So the maximum was 32 meters. The minimum was 2 meters divided by 2, and you get 17. So we are a vertical shift up 17 meters. So if we wanted to go back and graph that here, here would be y equals 17. This is our amp, right? Have we found all the things we needed? Did we find our A, B, C, and D? All right, let's go ahead and write the equation. All right, so our equation for our cosine function, our amplitude was 15, but there was a reflection, so negative 15. Cosine of our B value, which we found to be pi over 30, x, there was no phase shift, plus 17. Now if you want to change those variables to h's and t's, that's fine too. So you can write it as a function by just changing it to an h and a t.